In this video, we are going to focus on solving equations that are quadratic in nature. Now, a trinomial that is quadratic in nature means that this exponent is going to be twice the value of this exponent. Now, there are several ways to do this problem, but in the previous video, we spoke about using U substitution. Now, in U substitution, what we're going to do is get rid of this x squared and this x to the fourth by substituting in some u. So I'm going to let u equal x squared. Now, if I square the left, that's going to give me u squared, and if I square the right, that's going to give me x to the fourth. Now, we are going to use those values to simplify this trinomial. So in for the x squared, we are going to plug in u, and in for the x to the fourth, we are going to substitute u squared. So I'm going to rewrite this as u squared minus 37u plus 36. So let's solve this. I'm going to focus on factoring. So I'm going to break this up into a product of two binomials. The leading coefficient is 1, so this is going to be u times u. This means your operations are going to be the same, and this means they are going to both be negative. So now my job is to look for numbers that multiply to 36 but add to 37. Well, I know that that's going to be 36 times 1. Now, if that takes you a little bit longer, that's fine. Always take your time factoring. Now, at this point, I have used my u to factor my trinomial, and I'm going to go back now and resubstitute my x values in. So instead of having a u, this is going to be x squared. And here also, instead of having a u, this is going to be x squared. Now, zero product property tells us that each one of these binomials, when I multiply them, that's going to be 0. So I'm now going to solve this equation by setting each binomial equal to 0. Now, there are two different ways that you can solve this. This means here that there are going to be two solutions that come from this equation and also two solutions that come from this equation. Well, you can get the x values by themselves, or you can continue factoring. There is not a proper way, but I really enjoy factoring, so I'm going to keep going that route. This is what's called a difference of squares. I'm looking for numbers that multiply to 36, so this means that they are, one's going to be positive 6, one's going to be negative. You have a plus and you have a minus. Same strategy here. It's also a difference of squares. So one's 1, the other's 1's, 1 plus, 1's minus. Now I know the operations are opposite each other, so when I go back and FOIL, that middle term would drop out. So I have two binomials, each one, using that zero product property, I'm going to set equal to 0. So I'm going to have x equals a negative 6 and x equals a positive 6 from this case. And in this case over here, same strategy, set each one equal to 0. This is going to give me x equals negative 1, and this is going to give me x equals positive 1. Now, when I look back from the very beginning, this equation has an x to the fourth, which means there are going to be 4 solutions. Now, the other method I was talking about, if you chose not to factor, would be if you were to take this binomial that is already set equal to 0, you can get the x squared alone by adding that 36 over, and then you can take the square root of both sides. Now, anytime you physically take the square root, there are going to be two cases, plus or minus 6. And again, I know that because this exponent is 2. And you could follow the same strategy with the equation up here, which would be x squared minus 1 equals 0. Add that 1 over. Square root of both sides, again, has to give me two solutions. So this would be plus or minus 1. The same answers I got from my factoring method. Let's take a look at our second example. Again, I know that this trinomial is quadratic in nature because this exponent is 2 times or twice the value of this exponent. Let's go back and use that U substitution. So I'm going to let U equal my x to the 1/3. If I square the left, I get U squared. If I square the right, I get x to the 2/3. So let's rewrite this trinomial. I have U, again, my x to the 2/3 is going to be U squared, plus my x to the 1/3 is going to be U, minus 21 equals 0. Again, the goal behind this is just to clean up our trinomial so it's a little bit easier for us to factor. So my first terms are going to need to multiply to give me 2u squared. Well, 2 is prime, so I know the only thing that multiplies to 2 is 2 and 1. My 21, I could either use 1 times 21 or 3 times 7. I normally start with the ones that are the closest together. So I have to think about where I'm going to put that 3 and 7. So let's say I try it here. And my goal is the combination needs to give me a 1. So let's go through and check. This would give me a 3u. This would give me a 14u. Again, looking at my operations, this means you're going to have 1 plus 1 minus. This means the larger is going to be plus or addition. So the larger of these two has to be a plus. Well, if I add down, I get 11u. Is that what I wanted? Rats. No, I wanted a 1, which means this combination did not work. So instead of maybe putting the 3 and the 7 in those spots, let's try switching the placement of those values. So let's say now I'm going to give myself, let's put the 7 here and the 3 here. That's going to give me a 7u and a 6u. One's plus, one's minus. The larger of the two is plus. So that means this guy's going to be plus. This is going to be minus because the 7 is the larger of the two. And when I do add down, I get a positive 1u, which is what I wanted. So if I go back here, this is supposed to be a plus 7u and a minus 6u. So the subtraction is going to go in that spot. Okay, so let's get rid of my check here. Now, before I start to solve, I'm going to go and substitute those u values back in. So I have my 2 instead of my u. That's going to be x to the 1/3 plus 7. And in this u, I'm also going to substitute x to the 1/3. All right, so our next step is to set each of these binomials equal to 0. I'm going to get my x by itself. So I'm going to subtract the 7, which gives me 2 times x to the 1/3 equals negative 7. I'm going to divide both sides by 2, again, trying to get that x value alone. So now I have x to the 1/3 is equal to negative 7/2. Now, to get rid of this 1/3, I'm going to raise both sides to an exponent. And my goal is to make the current exponent 1. So I'm going to cube both sides. Because if this is 3 over 1, I'd end up with 3 over 3. as my ratio, and that would reduce to 1. So I end up with x. If I have a negative 7 and I'm going to cube that, I get a negative 343. And if I have a 2 in the denominator and I cube that, that's going to leave me with an 8. Same strategy on the right one. Add a 3 over to both sides. Gives me x to the 1/3 equals 3. And again, I'm going to cube both the left and the right to change that exponent value to 1. So I'm left with an x equals 3 cubed, which is 27. Our last example. I know again, this is quadratic in nature because the value of this exponent is 2 times the value of this exponent. I am going to let my u equal x cubed, and I'm going to let my u squared equal x to the 6th. So if I go through and substitute that in for my x to the 6th, I have u squared minus 7. In for x cubed, I have u plus, minus 8. Equals 0. That trinomial is going to factor into a product of 2 binomials. So since the coefficient here is 1, this is going to be u and u. This means that I have 1 plus and 1 minus operation, and this is going to be the larger of the 2 numbers is going to follow a subtraction. So looking at the different factors of 8, I have either 1 times 8 or 2 times 4, and I know when I combine those, I'm supposed to get a 7, so I'm going to look at this combination. If I plug the 1 here and the 8 in this spot, again, it told me 1 plus 1 minus, the larger is minus. So I'm going to put that subtraction in front of the 8, the addition in front of the 1, and I'm still going to go back and check. This product gives me 1u, this product gives me a negative 8u, and my sum is going to be negative 7u. And that is what I wanted up here. So I'm happy with that factored form. All right, now, before I solve it, I'm going to go back and substitute those values for u. So that's going to give me an x cubed plus 1 and an x cubed minus 8. Well, now this problem even becomes more complicated. If I go back to the beginning, I had an x to the 6th. So this actually means that I'm going to have 6 solutions. And if you look down at the step we are currently at, I'm going to get 3 solutions from this binomial, and I'm going to get 3 solutions from this binomial. So using my zero product property, I'm going to separate this into 2 different equations. The first one is going to be x cubed plus 1 equals 0, and the second one is going to be x cubed minus 8 equals 0. Now, I notice that since this is a cube, this expression is really a sum of 2 perfect cubes. And this one holds that same form. However, this one is what we call a difference of 2 perfect cubes. So let's start. Sum of cubes factors into a binomial times a trinomial. And I'm going to use my acronym SOAP. That stands for same. That original operation goes in that binomial. Opposite, always positive. So what did I cube to get x cubed? X. What did I cube to get this 1? 1. I'm going to square the first term. I'm going to square the second term. 1 times 1 is 1. And I'm going to multiply that x and 1 together. That's just going to give me an x value. Now, this binomial is going to give me my real solution, and this trinomial is going to give me 2 imaginary solutions. All right, so I know this gives me x plus 1 equals 0. So I'm going to have x equals negative 1 as my real solution. This trinomial I'm going to solve by using quadratic formula. And just to identify these values, the leading coefficient, that's going to be my A. This coefficient is going to be my B. And this value or constant is going to be my C. So I have x equals negative b, or the opposite of b, plus or minus the square root of b squared minus 4 times a times c. So a was 1, c was also 1, all over 2a. So let's clean this up a little bit. I have the opposite of b, so a negative times a negative is a positive. I have negative 1 squared, which is a positive 1. Negative 4 times 1 gives me a negative 4 all over 2. Keep going. Underneath now I have a negative 3. And I know I cannot leave a negative under the radical sign, and that's going to pull out an I. It becomes an imaginary solution. So 1 plus or minus I square root of 3 all over 2. So that is one answer that we're going to focus on. All right, the other one is also a cube value. So again, I said it's a difference of cubes. I'm going to factor that into a binomial and a trinomial. Same structure. Using my acronym SOAP. Same, opposite, always positive. What did I cube to get x cubed? Again, that's just x. What did I cube to get 8? That's going to be 2. I square the first one, x squared. I square the second one, 4. And I times them together. This binomial, again, is going to give me real solution. And this trinomial is going to give me 2 imaginary solutions. So let's use that zero product property. X minus 2 is going to equal 0. So 2 is one of my answers. Looking at the values of my coefficients, I have an A that is 1. My B is 2. And my C is 4. C is always my constant. So let's use our quadratic formula. So I have x is equal to the opposite of b, or negative b, plus or minus b squared minus 4 times a times c. So my a here was 1, and my c was 4, all over 2a. And a was 1. So this guy especially was supposed to be squared, b squared. All right, so I have a negative 2 plus or minus my b squared, which is going to give me a 4. I am subtracting 4 times 1 times 4. So when I multiply that together, I end up getting a negative 16 all over 2. So to keep cleaning this up, I have negative 2 plus or minus the square root of negative 12 all over 2. That negative 12 can reduce to plus or minus, and if I were to make a factor tree with that 12, writing kind of large, sorry, that's going to give me 4 times 3, or 2 times 2 times 3. I'm going to have that pair of 2's that are going to come out front, and I'm also going to have an I coming out because of that negative underneath. So I'm going to write this as a 2i squared 3 over 2. And I can actually go one more step with that, because each of these terms in the top, each of the coefficients of those binomials, can be divided by the 2 in the denominator. So this reduces to negative 1 plus or minus I root 3. So there you go. I had 6 solutions. My negative 1, my 1 plus or minus I root 3 over 2, my positive 2, and negative 1 plus or minus I root 3.